you have similar amino acids, they might not be exactly the same, right? But they might be the same in their function, their functionality. For example, where you're supposed to have adenine, it is similar, it is not the same, but they are both cytosines. They are both, sorry, similar amino acids or nucleotides in the same position across different sequences. That's what we know as sequence similarity. So the example I was giving was if you have adenine, right, in position 1 of your first sequence, and you have guanine in position 1, that's in position 1 of another sequence. They are similar, but they are not the same nucleotides. They are similar because adenine and guanine are both purines, right? But if you have maybe adenine and cytosine, so you have where you have adenine in one sequence, you have cytosine in another sequence, they are not similar. You can't refer to them as similar nucleotides, right? They are dissimilar because two of them are different. One is a purine, the other is a pyrimidine. And one thing about similarities is, sequence similarity is, the degree of similarity across sequences can be quantified. So you can quantify it. It has varying degrees. It ranges from 0 to 100 percentage, right? So to properly determine percentage of similarity between two sequences, the sequences have to be at least 100 amino acids or 100 nucleotides long, right? And when you have at least 100 amino acids or nucleotides, right, 20% to 25% in amino acid identity is required for two sequences to be known as protein homologs. So before you refer to two sequences as protein homologs, they must have 20 to 25% identity, similarity between them. While for the nucleotide, nucleotide has the higher threshold. You must have 70% nucleotide as gene homologs. Okay. So this is the example I was talking about earlier. So this is sequence 1 and sequence 2, right? Across this sequence, if we look at everything, like if we try to align them, you can see that where where adenine is, there's also adenine here. There's guanine where there's guanine. There is cytosine, there is cytosine, there's thymine, there's thymine, there's guanine. So here we can see that there is guanine here and there is adenine here, right? What I was talking about similarity. So here they cannot be 100% similar because of this. They cannot be 100% identical because of this. And these are known as point mutation, because both of them still have almost the same two at both pyrimidines. So here we have 90% identity and 90% of this formula. So for equal length, for two sequences of equal length, this is the formula we use: 2L divided by Ly. That's the length. L is the number of aligned residues. That's the number of similar nucleotides. The number of similar nucleotides amongst them. That's what L stands for. LY stands for the total length of the first sequence. LZ stands for the total length of the second sequence, then multiplied by 100. Then for unequal lengths, the formula is a bit different. For unequal lengths, we have LIS, which is the number of aligned residues. That's number of aligned sequences, meaning number of similar sequences between those two sequences that we have. And LY is the length of the shorter sequence between the two. So we're going to, that being said, I would want us to pause here. Please, do you have any questions before I go further, so I don't confuse anyone? Do we have any questions?
If you're not clear on anything, you can ask your questions.
Okay.
Okay, I think we can go ahead here.
All right. Okay, I think I see a question. What is the essence of sequence alignment? Sequence alignment shows the similarity between sequences. So sequence alignment basically, if, I don't know if you were here earlier, where I showed the importance of sequence alignment. So sequence alignment is used to, from sequence alignment, you will know the common answer used to match unknown sequences with known sequences, right? So for example, a new sequence that you just got from the lab, and you're not sure about what it is or where it belongs to, you basically align it on, sorry, I want to go back to okay, I think I removed it. Okay, so sequence alignment points out the relationship between two sequences, shows the similarity, and it shows the differences between two sequences. That's the simplest term I can use. So Mercy, was I able to answer your question?
Yes, you were. Thank you.
All right. So I'm just going to continue since there are no more questions. So we're going to be looking at the similarity or identity for amino acids. So unlike nucleotides, like I said earlier, the percentage identity and similarity are not synonymous. They are not the same. For nucleotides, similarity and identity means the same thing, right? But for amino acids, they don't. For amino acids, identity is when every single thing matches. Like you are not changing or substituting, making any substitutions for any amino acids across the two sequences. While for similar, there might be substitutions. Substitutions are still along the same, if the two amino acids have the same properties, right? You can still call them similar. So here, for example, this two we have here, you can see across them the first and second sequence. 100% identical. We don't have any substitute changes in any of them. And we also it is also 100. They are literally the same thing. The first sequence and second sequence are literally the same thing. Then the third sequence and the fourth sequence, this last two here, their identity has been tampered with. And that's because here, where we have alanine, right? Alanine, where we have aspartic acid, it has been substituted for glutamic acid here. Where we have lysine, it has been substituted for arginine here. And where we have tyronine, it has been substituted for serine here. So these two, the next slide will show you. Let me move to the next slide. So the next slide shows that these two amino acids have the same properties. That's why you can still say that they are 100% similar. So if you have changed it to, any other amino acid apart from glycerin, the similarity will be affected. But since both of them are neutral and non-polar amino acids, they are still similar, right? But their identity has been tampered with, because even though they are still similar, they are not exactly the same thing. So here too, we have negative charge and they are acidic too. Here they have positive charge and they are basic, and neutral and polar. So we're going to be looking at homology and similarity, the difference between homology and similarity. Homology is usually referred to as shared ancestry. Similarity usually refers to likeness, something that looks like the other thing, or the percentage identity between two sequences. Two sequences are homologous if they are derived from a common ancestral sequence. Similarity means having statistically significant number of amino acids or nucleotide-based matches. So similarity is usually calculated, right? It can be calculated, while homology can't. Homology usually implies similarity. For you to have shared ancestry, you would have similar sequences, right? But for you to be similar does not necessarily mean that you would have the same shared ancestors. So similarity doesn't imply homology. Homology usually implies similarity. So sequences are either homologous or not, right? You cannot say, oh, we have percentage homology. No, there's nothing like that. While for sequences, it varies in degrees, right? It varies. So it can be measured using percentage. That's why here it says that it means having statistically significant number. So it's something that can be calculated. Moving on to sequence alignment methods. So sequences can be aligned using, one, the global alignment method, and two, the local alignment method. Global alignment method is when you match as many characters. By characters, I mean either nucleotides or amino acids as possible across the entire length of the sequence, right? So here, as we can see that they're trying to match these two sequences, and we can see that there are gaps here, right? And we're trying to match them across each length. While for local alignment method, it focuses on the best matching regions. So it just focuses on regions that have the best or the highest scoring regions, the regions that have the best matches. right? So here we can see that it is focused on just one region here, right? Not the whole length. It is focused on one region, while this one focuses on the whole length of the sequences. So the differences between local and global alignment. For global alignment is used, or is better when it is used with sequences that are more closely related, right? Sequences that are quite similar to each other. While for local alignment, sequences that are similar, they don't necessarily have to be similar like throughout the length. So far they are similar along some of their regions, because it's not the whole length you're doing for local. You're doing the best matched region, right? So sequences similar along some of the lengths, but it can be dissimilar in the others. You don't actually care because you're focusing on just one region, right? So for sequences that are more closely related, global alignment is used. For sequences that are not, that are quite dissimilar, you can use local alignment for it. So far, they are matched along some of their regions. For global alignment, it is used on sequences of approximately the same length, right? They might not even be exactly the same, right? But they are very close to each other. Most of them are usually like the same length. While for local alignment, you have sequences that differ in length. You can have a long sequence and a short sequence. Global alignment is made possible by including gaps either within the alignment or at the ends of the alignment. While gaps are not tolerated in local alignment, we're going to be looking at gaps in next slide. So overall goal when you are aligning, pairwise alignment is when you align two sequences, right? While multiple sequence alignment is when you align two or more two or more than two sequences majorly. Pairwise is for two, multiple is for more than two. So the overall goal when you are trying to find an alignment between two sequences is to provide like the best. When I mean the best, that's the most matched pairing between the two sequences. So for you to actually find that, sequences have to be scored. Sequences alignment have to be scored to identify the best local alignment method, right? So, sorry, can you still see my screen?
Yes, we can.
Okay, thank you. So the sequences have to be scored to identify the best ones amongst them. So for the alignment method, for the pairwise optimal alignment method, we're basically just looking at the best pairing between the two sequences. So we employ a scoring scheme. There's a scoring scheme that we use to reward matches. So when you match, when one sequence matches with the other sequence, you score it like it's a positive, while when there are mismatches or when there are gaps, it is punished in quotes. So they are negatives. We'll be looking at that in the next slide. So the similarity between two sequences usually have high scores, while the similarity between two sequences usually have low scores because of the mismatches and the gaps. So treatment of gaps um, basically means when you are looking for your optimal alignment, how are gaps treated? Gaps are these spaces that you find between sequences. These spaces, they are called gaps. So anytime you see there's something called a constant gap penalty. A constant gap penalty is when you have a negative score, right? A fixed negative score for the gap, irrespective of the length of the gap. So for example, this alignment here, we have 3 gaps, but the score rules for constant, that's why the word constant is there. So it doesn't matter the number of gaps you have, right? It doesn't matter the number of gaps you have. For everything, you're scoring the gap -1. So I want us to do this
Are you
together.
doing? It looks like your voice is breaking.
Oh, wow. Oh, can you hear me
Yeah,
now?
maybe it's network. Yes, we
I
can
think it's
hear
network.
you
Okay, so
now.
sorry, what was the last thing you heard?
Mm, okay, I think about you want to move to this, yeah, to this slide.
Okay, did you hear everything I said about the constant gap penalty?
Yeah, we did.
Okay, so it's just the alignment that I said we're going to do together. So
All right, yeah.
all right, so I don't know if we are with, just follow me as I say, and if you have a pen and a paper with you, you can just write the sequences down. So sequence 1, we have G C T G A T T C A T, right? And for sequence 2, we have G C gap 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 T T C A T. Okay, so if we're asked to calculate the alignment score of this sequence, these sequences, the rules here, each match has plus, and the gap, irrespective of how many they are, the gap is -1. So we're going to match together. So G and G is a match. That is +1. That's 1. C and C is a match. That is +1. That's 2. These gaps are 3, but because the rule says the gap, irrespective of whatever they have, is -1. So for these 3, we have -1. So 2 max is -1. Um, so T and T, we have +1. That's 0. That's -1 plus 1 is 0. Um, T and T, we have, thank you, Esther. Thank you. T and T, we have +1, and we have +1, and +1, +1. So when we add up everything together, we just, yes, Mercy, the 3 gaps are -1. That's why it's called a constant gap penalty. 3 of them are -1. But even if you had 5 of them here, it will still be -1. So when we move on to the next type of gaps, you would see another example. So before I go on, do we have any questions? Hope using anyone. In this region as and as minor, right? But so far they are in the same region. They are this multiplying it by 3 or multiplying it by 4. Everything still remains. I answer your question. Go to me, please indicate if I've been able to answer your question. Okay, thank you. So for Barakat, let me go over the calculation again. So we have two sequences. We have GCTG, ATT, CAT, and we have, for the second sequence, we have GC, we have three gaps, we have TT, we have CAT, yeah? So this penalty rule states that any gap you have, so far they are in the same region. Let me put that caveat. So far they are in the same region, the score is -1. So even if there are 5 gaps following each other, it will be -1. While for every match you have, a match is when across both sequences, they are exactly the same. There is no dissimilarity between them, right? There is no substitution between them. G is the same as G. Cytosine is the same as cytosine, like that. So for every match that we have, let's calculate the matches that we have. So across this, we have 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, 7. We have 7 matches. So for these gaps, these 3 gaps, we are subtracting 1 from that 7. That's how we got 6 for the alignment score. Barakat, do you understand now? Okay, thank you. Thank you. So I'll be moving on to the next one. Next one is linear gap penalty. Linear gap penalty, you're not calculating it using regions, you're calculating it per gap. For example, if I say the score of a gap is -1 and you have 3 gaps, it is -1 for one gap, -1 for the second gap, that's -2, -1 for the third gap, that's -3. So if we're to calculate this one, we're going to, each match is +1. It's the same rule as the other one we just finished. So this is 1 + 1, as 2 + 1, 3, 4, 5, 6, 7. So for this one, -1, that is 7 minus 1, that's 6. 6 minus 1, that's the second gap, that is 5. 5 minus 1, that's the third gap, that's 4. So the alignment score for this is 4. Do we understand? If I'm confusing you, please let me know. Okay. So we're going to move on. So from both of them, we could see that, thank you, Martin. From both of them, we could see that constant and linear gap penalties, they don't consider whether the gap is opening the sequence. By opening the sequence, I mean, let me show you. So the gap can be here, right? Or the gap can be here. They don't consider that in the penalties, but gaps at the terminal region, that's gap at the end, gap towards the end, you usually don't have penalties for that. So for example, if we have these gaps towards the end, we are not going to be calculating, we're not going to be subtracting anything from this alignment score. So gaps towards the end are not counted. It is only gaps at the beginning and gaps extending. By extending, it means it can be found after the beginning, middle, but before the end. But so far it has gotten to the end, like the sequences have ended and there are gaps, you're not calculating it as a gap, just going to leave it black. You're not asking score to it. So affine gap penalties, it considers the opening gap and the extension of gaps. By opening, I explained earlier, when a gap starts a sequence, and extension is when it continues, right? So for the affine gap penalty, for you to calculate the total gap penalty, you have G, that's the total gap, equals O, that's the opening gap, plus the extension penalty, right? Into brackets, the length of the gap and subtracted by 1. So this formula, the opening gap costs more than the extending gap. So for example, we're going to go back to that question, right? And we're going to use the formula for that question, but we're going to fine tune it. I'll try to fine tune it. So for example, the opening gap can be -2, but the extending gap must not cost more than it. It must cost less. So the extending gap will be -1. So if the opening gap is like -4, the extending gap will be from -3 below. And it is more evolutionary sound actually to use the affine gap penalty, because you're considering the opening gap and the extending gap. But the drawback is that the penalty points are randomly chosen. By penalty points, I mean the score you give to every gap. You know, for every gap, it has a negative score. The score you give to every gap is called a penalty point. You just randomly choose it. You randomly assign it. You can choose it on your own. There is no threshold for it. You are just randomly, and that might not be as accurate the other ones that we looked at. Okay, so we have gotten to the practice point. Does anyone have any for before I move forward? Any questions? Any questions? Okay, we don't have any questions. So like I said earlier, today's today's training was just an introduction to sequence alignment. Okay. Does that mean that we can use any penalty for the gaps? It actually depends on the penalty. For example, it depends on what you're trying to achieve with the sequence alignment, right? So if you want, for example, if you have like short sequences like the one I showed you before, like this one, you don't need to go for affine gap penalty, because for affine gap penalty, there are no opening penalties for the gaps, right? There are no opening gaps here, so you cannot even use it. So it actually just depends on what you're trying to achieve for your sequence alignment. And for the affine gap penalty is the one that you can randomly choose penalty points. Usually for the constant and linear, penalty points are usually given, right? But for affine is you are the one making your decision by yourself. So it makes it it can make it less accurate, right, than the others. I don't know. Have I been able to answer your question, Rotimi? Thank you. So we're going to practice now. since no one has questions. And like I said earlier, the reason I did not touch on multiple sequence alignment is because you need to understand pairwise. Pairwise is for just two sequences. Multiple, you can align as much as 20 sequences together, even more than that, right? So if you don't understand this one, and you even need to know why you're doing it. So that's why I took like the introductory part of it for this training. Because if you're relying on the software, we have tools that, but a lot of times you just impute, they'll just tell you, okay, go to this one, press this one, and then it brings out your alignment. You don't even know what it does. I'm sure you don't even understand the results. Do you get? That is why I did all this today, for you to understand what sequence alignment means, the purpose, and the methods used for sequence alignment. So we're going to practice. Yeah, we're going to practice. These are the practice questions. So I'd like us to I would like them, if you want to say your answers, please indicate. And you can also drop it in the chat box. But I would really, really like everyone to do them because I'm going to do them myself. So I'm going to give us 10, 10 minutes much. I'm going to give us like 5 minutes to do them, and let's see where everyone gets to by then.
Thank you, Adedayo. Well done.
Thank you. Please let's all try to attempt this. Thank you. anyone done? Anyone? Or should I call names? Anyone? Do we need to see the formula for number 3 again? Because I can see that no one has given us number 3. Okay. So this is the formula for number 3. Taking it off in 3, 2, 1. Has anyone attempted number 3 yet? No one? Shinaz, have you been able to attempt number 3 yet? Hmm, 10. Okay. Let me show the sorry. Let me show the formula again. Okay.
Can we get the formula again?
All right. Here, this is it. G gap equals opening penalty plus extension penalty into brackets, length of gap minus 1.
All right, thanks.
So let me go back to questions. See, we're going to do it together. I want to be sure at least How many are we? I'm seeing I'm seeing 1, 2, 3, 4, 5, 6, I think 7 attempts. I think we should be able to get at least 10 attempts. We're 21 here. Please, if you've not attempted it, please, let's try to. Thank you. So I'll wait for 2 more minutes before we try to do it together. Okay, let's do it together then. So the first one, sorry, let me. Please hold on. Okay, so question 1. By using the constant gap penalty, question 1. So the score rules, each match costs +1, each mismatch costs -1. The constant gap is -2. So we have 1, 2, 3, 4, 5, 6, 7. We have 7 matches. So that's 7. So our score is 7 at the moment. So we have 1, 2. We have 2 mismatches. That is -2. So our score is at the moment 7 minus 5. So for the, if you remember, the constant gap penalty states that once you have, no matter how many gaps you have in a region, the gap penalty is constant. So the gap penalty is -2. So we have 5 minus 2. The answer is 3. I can see that quite a number of us got that correctly. See that quite a number of us got that correctly. Okay, so we're moving on to the second one. Does anyone have a problem with the first one I just solved? Are we fine with it? Okay, moving on to the second one. The second one we have match +1, mismatch -1, the linear gap -1. So for the matches, we have 1, 2, 3, 4, 5, 6, 7. we have 7 matches. So that's 7, right? And then in mismatch, we have 1, 2. We have 2 mismatches. That's 7 minus 2. Okay. Then for the linear gap, each gap counts as minus 1. So we have minus 1, minus 1, that's minus 2, minus 1, that is minus 3. So we have 7 minus 2 minus 3. So that's what? 7 minus 2 minus 3. That's 5 minus 3, that is 2. So our second answer is 2. Are we fine with that? Do we understand? Hope everybody understands. Before I move to the third one. Okay, so the next one, I think the third one is the one we had issues with. So the formula for thank you for the feedback, everyone. So the formula for gap, for the affine gap, is the total number of your gap equals the gap opening penalty plus the gap extension penalty into brackets, the length of your gap minus 1, close the bracket. So I think a lot of us had issues with it because we were calculating just the number of gaps. We did not add matches to it. And also, let's just do it. We'll start by calculating the number of gaps we have. So gap equals, we don't have any opening gap here because every gap that we have is extending. Like I said earlier, opening gaps are gaps that start a sequence, right? And we don't have any here. Each of them, this is one sequence. Each of them are extending into the sequence. They are not opening the sequence. So we are only calculating for the extension penalty. So the extension penalty is, so we're going to be using 0 as our opening gap because we don't have any. 0 plus the extension gap, the extension penalty is, we have from minus 2 is the extension penalty. So we have minus 2. So remember, in the formula, they did not say you should multiply like the extension penalty by the number of gaps, right? We're just supposed to write the extension penalty. So that's 0 minus 2, 0 plus minus 2, which is also equals to 0 minus 2. So we're opening the bracket. The number of length, that's the length of gaps that we have. We have 1, 2, we have 1, 2, 3, 4, 5. We have 5 gaps. So we're calculating both the gap in the first one and the gap in the second one. That's the total number of gaps. So 5 minus 1. So we have 0 minus 2 into bracket 4. That is minus 2 times 4. That is minus 8. So minus 8 is the total number of gaps that we have. So to calculate the alignment score, we are going to keep that total number of gaps and calculate the number of matches and mismatches and add everything together. So our number of matches, so for each match you have plus 5. So we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 matches. So that is 8 times 5. 8 times 5. 8 times 5 is 40. That's the total number of match that you have. So total number of mismatch is -4. And we have two mismatches. We have this one here, we have this here, and we have this one here. That is -4 times 2, that's -8. We have 40 minus 8 minus 8. So that is 40 minus 16. Our answer is 24. How many people got 24? Do we understand? How many people got 24? Do we understand? Are we clear? Okay. Okay, someone doesn't. All right, so we would let me just quickly take us through it again. Okay. I would go over it again. So to go over it, I'm going to go to this affine gap, right? So affine gap penalty considers the opening and the extension of gaps, right? So the opening penalty and the extension penalty. The opening penalty and the extension penalty, and the length of the gap. So this is the formula we're using. Our formula is this formula is not to calculate the is to just calculate the gap, the penalty for the gap, right? But what we are looking for is not the penalty for the gap. What we're looking for is the total score for the pairwise alignments, which involves the gap, the match, and the mismatch, right? So since I've established that, the formula we're using is G, that's total number of gap, equals opening gap plus extending gap times length of gap minus 1. So we have total number of gap equals our opening gap. We don't have any opening gap. Opening gap is usually found at the beginning of sequences. So we're leaving it as 0, plus the extending gap is the gaps that are found in one I did earlier to calculate, multiply this, we're supposed to multiply the gap penalty by the number of gaps that we have, by the number of gap extensions that we have, sorry. So for this, we have a -2 for each gap extension that we have. So, and we have 1, 2, 3. We have 3 gap extensions here. We have 2 gap extensions here, and that's 5. So we have -2 times 5, that is 10. So into bracket, the total length of our, what do they call it? The total length of our gaps are 5 too. So 5 minus 1. So the total number of gaps is 0 minus 10. That's into bracket 4. So total number of gap is minus 40. Can everyone hear me?
Yes, we can hear you.
Okay, let me go on. So we have our mismatches, our matches. Our matches are 1, 2, 3, 4, 5, 6, 7, 8. We have 8, that's 40. And we have 2 mismatches, that's -4 times 2, that is -8. So And our number of gaps is minus 40. So our total alignment score, alignment score is minus 8. Do we understand, or am I confusing you? Godfred, have I been able to answer your question? Do you understand now? Genesis, do you understand it now? Okay, Mercy, how do we arrange the last calculation? So we arrange the last calculation using sorry, we arrange the last calculation using the formula. We'll first calculate the number of gaps that we have, right? So when we calculate the number of gaps that we have, we calculate the number of matches we have and the number of mismatches, sum everything up together, and that is our alignment score. Do you understand?
Sorry, if I get you correctly, you mean
Yeah,
total number of gaps minus the matches minus the mismatch.
exactly.
So that should not give us this thing now. I don't think it should give us 8 minus 8. Abi.
Okay, what is it giving us? Or what is it
Since
giving
total
you?
number of gap is minus 40,
Yes.
minus 40, then the 8 matches, that's minus 40 minus 40 minus 8 won't give us minus 8. So that's why I was looking for the order, because
Or
it's
what will it
giving
give us? 40
minus
minus,
84, minus 40 minus 40
no,
minus
no,
8.
no, no. Your match is not carrying a negative sign. Your
That's
match is carrying a positive
that's
sign.
what I'm
So,
saying. I want to know the order. Matches,
okay.
the match will come first, minus the total number of gap before the
Yes,
mismatch. That is the order I want
yes,
to know.
yes.
Oh,
That is what is coming
okay, thank
first. So
you.
it is the total number of match first
Okay,
minus your mismatch, then your gaps.
all right. Thank you.
Okay, thank you, Adedoyin. We have just a few minutes to our closing time. I think Paul is raising up his hand.
Oh, okay.
Hello, can you hear me?
Yes, I can.
Okay, so thank you for the explanation. But I'm still trying to get your explanation concerning the opening gap. The way I understand it, I think each gap, when you're starting a gap, opening a gap should carry a penalty, then extending it, not necessarily when starting when having a gap at the beginning of the sequence. I don't know if you get what I'm saying.
I understand you. I understand you. Okay.
So that's the way I think, that's the way I understand it.
I
I
think
don't
that
know
can
if,
actually be applied to. Yes, I actually do get you. I do get you. So the thing is, um, from as the thing is from several resources. Yes, I'm on the group chat. From several resources, we see people calculating it differently. So I read some resources that you do not multiply the number of gaps, right, by the penalty score you are giving for a fine penalty, right? And there are some that you actually multiply it. So I think at the end of the day, I actually need to find out which is the generally accepted one. Thank you for pointing that out. I will find it out and then I will correct it if what you said is the generally accepted one. I'll find out, I'll correct it in the slides before I share them to the group. Thank you.
You're welcome.
Thank you so much, Adedoyin, for this very insightful session. I mean, like your teaching skills is so much enviable. Like, thank you so much. I think we have come to the end of this session for today, and I believe that you would agree with me that it's been a very enjoyable journey. If you have any other question for Adedoyin, you can reach out to her on our WhatsApp platform. You can just check, you would see our contact as Adedoyin. Thank you once again. Thank you so much. I mean, the love is just pouring in. Thank you. Yeah.
Thank you,
So,
everyone. Thank you.
yeah. So we have come to the end of the session tonight. Have a great evening, everyone.